So we have been dealing with objects in SFML pretty much by drawing them and moving them when we get input. And so you press a key and something happens. A lot of times, though, obviously you'll have games that need to move objects by themselves. So projectiles, you'll take a look at Angry Birds or really any FPS game out there. Bullets and enemies all need to kind of move on their own. So you need to learn how to manage velocity in your game because it's such a core concept that it's used kind of everywhere. And when I say velocity, I really mean a direction with a speed. That's what velocity is. Velocity is a change in position over time, which means that it explains how fast something moves, right? You guys all kind of get the concept of velocity, right? Velocity is used in 2D and 3D games, obviously, and it's typically represented by what are called vectors. So vectors are a way to denote a direction and a speed. They're just two numbers, basically. It's like how fast are you moving horizontally and how fast are you moving up and down. And that how fast you're moving can be in different units based on what engine you're using or what game you're playing. So for us, the units we're going to be using is how many pixels per second does this ball move. But in a game like Overwatch, all of our velocities are in meters per second, which means all of our projectiles move in a meters per second frame of reference. In Unreal, they use Unreal units per second, which is close to meters per second. Other games might use, I don't know, yards, feet, who knows. When you're dealing with physics, typically you use meters per second because they translate well when you're going up in numbers, right? So, like, if you have, you can easily go from millimeters to centimeters to meters per second if you need to. So that's why things are typically represented by meters. For games, though, pixels per second are fine for our little 2D game. If you wanted to use meters per second for this game, you'd have to define how big is 1 meter on screen. So maybe, for instance, we could define that this green circle could be 1 meter across if you wanted to. But keeping that in mind, it's important to know that velocity is something that is consistently applied. Velocity, you will apply those changes to your position pretty much as often as you can, and typically is represented as a per second unit. Which means that, like, for instance, I want this green ball to move across the screen in a certain amount of time, or I want this ball to move across the screen at a certain speed, pixels per second. Okay. So the typical way you do this is that you have something in your game, you create a velocity, and then you apply it to your object every frame. So let me just show you what this kind of entails. Because I have 2 labs for you today, which consist of like several problems each. So this green ball here is a very simple idea. And velocity is really no more than changing the position of this thing every frame. So up to this point, we've really been using the built-in behavior to move an object. So here's my ball. And if I wanted this ball just to move to the right, I can call this function on my shape called move. And I can say move this many units to the right, which will cause it to move from left to right, which is great and all. But how fast is this thing actually moving? Can anyone actually tell me definitively, based on this number, how many pixels per second this ball is actually moving? 1 pixel per second? It's moving a lot more than 0.1 pixels per second. If this screen, how many pixels wide is this screen? It's 1024 pixels, right? It has 1024 pixels across. So the time it takes to move across the screen, I don't know, 10, 15 seconds, maybe? But that number actually changes every time I run it, to be honest. Like, depending on what I'm doing, like if I wiggle this thing, right. So, yeah, what's up, Dom?
Because mine is doing it much faster than
Yeah, mine was moving really fast.
Yeah, probably because you're running less stuff than me. Like, watch what happens to the ball. I can actually slow down the ball movement by doing this. Can you guys see this?
If you turn off OBS, it'll probably be a lot slower.
Because they're a lot faster.
Oh yeah, because I have OBS running and it's actually taking up a lot of CPU power. Also, if I do funky things, I can actually slow down the movement. Like without touching this, if I do something like, let's just loop. And I'm just going to loop 1,000 times. Let's just do 100 times to start. I just have a counter. I'm just going to add 1. Let's do one more thing. Let's do 1,000 times through. Oh, it's probably getting optimized out. Let's just do this. I'm going to do some work here just to prove that the amount that this thing, how fast it moves is completely dependent upon how fast my computer is actually running. So there's my ball.
So it's only moving every time it takes to 1,000?
You guys see it's actually moving? Yeah, it's only moving every time it spits out 1,000. It's not even when it ticks to 100. It's actually when it's done doing this work. So I'm just going to print out 10. I'm just going to print out to the console 10 times. Look how fast it's moving now, right? It's completely dependent upon what I'm doing. And look what happens when I lower the window and bring it back up again. Look, the ball's moving slower just because I have this thing on screen. Look, I move it on screen. So that behavior right there, that's how we've been moving things so far, right? Which is fine and all, but I'm going to teach you guys today how to move things properly without using this function here with a hard-coded number right here. So the key is that this number right here is based on some arbitrary amount that I want to move, right? And what I really want to do is I want to move this thing based on a time, right? So there's a lab on this, but I'm going to show you exactly what I mean because you're going to have to do this in your lab. We're going to use what's called a clock. And so I'm going to call this my clock. So a clock is really just nothing crazy. It's basically a way for you to measure how much time has passed from when the program has started. Also, it lets you measure how much time has passed between subsequent calls through your loop. So every time through your game loop, you can figure out how much time has actually passed. So clock typically has another variable type that's associated with it that you use often with it, which is a time. So in the time, time is a variable type. I'm going to call this thing my time. Time itself is a way to read the clock, essentially. Just like how if I ask you what time it is, you have to look at the clock to figure it out. Time here uses the clock to figure out how much time has passed since the last time you cared about it. So in this case here, you're going to set my time equal to, you're essentially asking for how much time has passed. You're going to every time through your loop, you're going to actually restart your clock from 0 again. Restarting the clock means that, hey, I was counting this much time. You told me to start over at 0. It's like pushing a button on a stopwatch to reset it. And not only are you resetting it, but at the same time, it's telling you how much time has passed since the last time you reset it. Which means now my time here represents what we call the delta time, which is how much time has passed since the last time I called this function, which is the delta, the difference that has passed since last time I restarted the clock. Delta is just the difference. So now that this thing stores the difference, I can call this thing delta time, because that's technically what it is. This is a very common thing. You can also call it dt. You'll often see this passed into functions as a time. So you'll get this thing as like, hey, this is how much delta time has passed. That's what dt stands for. Now here, I can use delta time. So if all I do is I'm just going to print it out here, the dt is, and there's a function you can call on this time variable. There's 3. You can get time either as microseconds, as milliseconds, or as seconds. So milliseconds is 1,000. There's 1,000 milliseconds in a second, and there's 1,000 microseconds in a millisecond. So I just want it as seconds, because I want to know exactly how many seconds have passed. And if I run this and I see the output of this, I might need to do an ENDL here. I'll just put an ENDL so it actually prints out new lines. So there are my delta times, and I've shown this to you guys before, but this represents the time that has passed. And why is this important? Well, this represents the real time in seconds that have passed for my game. If I know this amount, I can control how much I move my object. So if, let's just say I want my object to move across the screen in 1 second, right? So here's my game. This screen is 1024 pixels wide. Can anyone tell me how fast this ball has to move in pixels per second to get across the screen in 1 second? 1024? Okay. What if I want it to go across the screen in 2 seconds? How fast does the ball have to move? 512. How did you know that?
You should divide it by 2, isn't that?
Well, how did you know that it was 1024 to start?
Because you are planner is 1024 at the very beginning.
So, yeah, I know I want this ball to move across at 1024 pixels per second, right? Which means that as soon as 1 second has passed, this amount that the shape has moved better be 1024 pixels, right? So how do I do that, though? How do I figure out what number do I pass in here to get it to move 1024 pixels over 1 second? Well, this dt here is telling me fractions of a second, right? It's telling me how many fractions of a second has passed since the last time I called it. How can I use this, which is telling me how much time has passed between the last frame, and the knowledge that I want to go across in 1 second together to move this object? What happens if I just do 1024 here? How much is that going to move? How many pixels is that going to move?
Couldn't tell you. I still don't know what point 1.
Yeah, we don't know. Like if I did 5, you don't know. 56, who knows? 0.01. You don't actually know how much this is. However, you know that this represents the time that has passed since the last time I called it. So what if I took that movement across the screen? Right? What if I took this movement across the screen? Then I know I want to move it in 1 second. What if I took this and I broke it up into tiny sections? So like, oh, how about every time I call this loop, I know how many fractions of 1 second I have. Like this right here is representing how many fractions of a second I've moved. So if I know this, which is how many fractions of a second I have, how many times does this get called every second? Well, if I do this, what is the speed of my shape moving from left to right?
Once every second.
1 pixel per second. That's the speed of my shape right now. If I just pass in this. How does that work? How does it know? How does that make sense, right? How do you know that it's actually only moving 1 pixel per second here? Because this is actually now it's correctly moving here. Let me run this. Remember, these are really tiny numbers here. But that ball, guaranteed, is moving 1 pixel per second now. No matter what I do here, no matter what I do in the background, so again, I can bring this thing off or on. Notice that doesn't change the behavior anymore. It's moving this way because this is representing how much time has passed in real seconds from the last time I called it. Which means this thing right here represents the fraction of 1 second every time. So if every time through this loop, I'm basically moving it this amount, watch what happens when I change the output here. So I'm going to show you guys this idea. I'm going to take this elapsed time here, I'm just going to add this delta time. Let's do this. I'm going to print out the time that's elapsed. So watch this. Does this look like a clock, right? It's counting up, and every second's going up 1. This right here is essentially adding 1 to this number every second. Just like it's adding 1 to the movement of this ball every second, right? Imagine this is representing the x position of the ball. We are adding a little bit to the x position every time through the loop. Which means here, this is moving a little bit every time too. I'm adding x position here at the same time that I'm actually adding the time here. So this thing represents how fast the pixels actually move.
So the ball's currently at like 52
Yeah,
right there.
exactly. You can see here, this, even though I'm adding time, this is basically showing you what the value of it is, right? This has a velocity of 1 per second. It goes up one number every second, right? How do I make this thing go up 2 every second?
2 times delta.
2 times, right? If I want this thing to go up twice as fast, I can do this, right? 2 times this. What if I multiply this by 2 at the same time? Just like I'm doing the same code here. I'm multiplying 2 here and 2 here, okay? Just to keep them in sync. So watch the numbers. This is going up twice as fast now, right? Can you guess that the ball would also be moving twice as fast now?
I mean,
Hard to tell. Why don't we make it a little bit more obvious? What did we say was the pixels per second we needed? 1024? What if I do this? I multiply by 1,000 times faster. So watch what happens to the ball now. But look, it went across in 1 second. What if I said I wanted it to take 4 seconds? Why don't I divide this by 4? So now you can be guaranteed it's going to take 4 seconds on the dot before that ball goes off.
So do you have to use both of those in conjunction with each other to achieve the same effect? Can you use one of them?
No, this right here is just for you guys to see, right? Like this elapsed time is only for, I don't need this. I'm just going to delete that. I'm just doing this for visibility's sake. This right here is why that works though.
Okay.
The reason why I was showing you that is because that's the logic that you're using to get this number right here, the 256.
Makes sense.
That is your velocity. That is the amount of, that is your units per second that you want this thing to move. This might, if this represented meters, then my ball would be moving 256 meters per second, right? It doesn't really matter what the unit of measurement is as long as you figure out what your, how your window represents that. So if I want this thing to move, now it'll take 8 seconds to move across, right? All right. So I have a lab for you, and the lab has 2 parts to it. One, I want you to implement the lab the old method without using this clock. That's number 1. Here, let me go over that with you. And then, are there questions on this?
Do
by the
they
way?
use that, like, this, like, program, like, move, like, when you're, like, if you have a hot, like, really good computer, right?
Mhm.
And, you're playing a game, like, do they use this type of program to, like, determine how good is your computer?
How good is your computer?
Yeah.
How many? Well, like this represents the FPS. Like if you wanted to know how much FPS you were getting, you could do this. Okay. So you can just easily figure out your FPS by doing this. So you see here, 400 and something frames. Sometimes I get to 125 frames per second. Sometimes a little lower. Sometimes 43 frames per second. This delta time here tells you everything you need to know about how fast your computer is for the most part when it's rendering the game. All right.
Hold on.
Yeah.
What happens when you change it to like milliseconds or?
Oh, you mean this thing here?
Yeah.
So remember, milliseconds, there's 1,000 of them in there, right? So if I actually print it out, it just means that it's basically you do this, you can get the same thing. You don't even need that function. Now that's in milliseconds. This represents milliseconds.
Oh.
So you're basically multiplying it by 1,000. If you want microseconds, then you multiply by another 1,000 on top of that. Yeah. Yeah, I mean, if you need the precision, you can do that. Like, there's really internally, there's only one variable where it's storing it, and then it just gives you back like this number. So yeah, either way, whatever you need to use it for. If you need milliseconds, which typically you don't in most cases for velocity. In velocity, you're doing everything within meters per second or something per second. And so you don't typically use milliseconds for that. Okay, so here's a lab. So there are 3 parts to it. The first piece is moving a ball without velocity. So this is, hey, I want you to move a ball in a direction, and then I have you press, then here's the interesting pieces, which I haven't shown you, which you're going to have to figure out, is I want you to press space to start the movement of the ball, which means the ball doesn't start moving automatically. You must press a button to start moving it. And then finally, I want you to make pressing space move the ball in a random direction. Okay? That is, it can go up and to the left or up and to the right or somewhere in between. Then the second lab is moving the ball with velocity. So it's basically using the delta time stuff that I showed you. So here's the example code for how to do that. And number 5 is I want you to move the ball from left to right in 3 seconds. So I want it to take exactly 3 seconds to move from left side of the screen to the right side. Okay? There's another one where I want your ball to move at 100 pixels per second. So there's two lab numbers which kind of like show you how to change velocity. Number 6 is an interesting one. I want you to move your ball 100 pixels to the second down and to the right. It seems simple enough. It's just down and to the right. It's just 100 pixels in x and y. But that's actually not correct. You guys remember your Pythagorean theorem? Anyone remember Pythagorean theorem? You guys remember? A squared plus b squared equals c squared, right? Who thought you'd be using that, right? The problem is, if I tell you to move in C, I want you to move 100 pixels this way. What do these 2 numbers have to be?
You want to say it again? Say it again.
I'm going to give you C. I'm giving you 100. What are A and B in that case?
For A and B, if A squared plus B squared equals C squared.
Yeah. How do you solve for A and B? So that's number 6. I gave you a link on how to solve it. It uses SOHCAHTOA. Does anyone remember SOHCAHTOA? Sine, cosine, tangent.
Oh man.
If you guys want to become programmers for game development, you have to know your SOHCAHTOA. It's basics. So we're going to learn. If you struggle on this, there's a link I give you on how to solve for this. The key is that if this is 100 and this is 100, what is C? It's 141 pixels. So if I tell you to move something at 100 pixels per second this way, and you type in 100 and 100 here, it's actually going to move faster than 100 pixels per second. So that's the problem for that one. I gave you guys a little bit of a challenge, but you have to use SOHCAHTOA. I give you a link to here to solve it.
That's true.
Yeah. It's not really that much trig. It's just a little bit of trigonometry.
No, I know.
Just like the slightest little baby. It's like baby trig. It's like it's tricky. It's tricky. You have to think about it. But once you have this formula, I'm going to ask you to do a couple other numbers as well. So how do you make something move like 50 pixels diagonally, right? This is very common. Like, rarely are you shooting, if in Overwatch, I'm never shooting just like down one axis. I'm always shooting like angles, right?
Yeah.
So how do you keep those speeds of the projectiles consistent no matter how you're aiming? Well, guess what? You need to learn how to actually rotate something so that you get the velocity that you need. Everything in games has an X component, a Y component, and a Z component. There's no such thing as an in-between component, right? There's like in a game, in a 2D game, when you have to move something diagonally, it's not actually, there is no such thing as a diagonal vector. It's actually all, like if I ask you to move, if I have a screen here, and I ask you to move something this way, you know what that actually is?
Yeah, right.
It's some amount this way and some amount this way. You add those two together and you'll get movement this way. You can't specify a number that's like that way. Every time you do something that's an angle, you specify X amount and a Y amount. Even if X is like, I don't know, maybe it's like 42.678 and Y is equal to 83.47. Those two combined might give you like a velocity of like, I don't know, 55 or something that way. This is why it's important to know this, because we're going to soon start getting, like if you ever want to make like an asteroids game, or you want to make like a Geometry Wars style shooter, or like a zombie shooter or something like that, you will be rotating the direction that you want your projectiles to fire. Just like how we're rotating the direction of the ball to move in a specific direction. That's why this right here is important. Number 6. Okay. And then number 7 is I just want you to replace the numbers you typed in to move with a couple of variables, because we're going to be using that here when in the bouncing the walls. So I'm going to have you guys do the bouncing. Bouncing is kind of an interesting thing. All you need to do in a game to make something bounce is reverse the direction that it's moving. Right? And you reverse the direction that it's moving, you just flip the direction. You go from positive to negative, or you go from negative to positive. How do you flip something from positive to negative in programming? What's the easiest way to do that?
Multiply by -1.
Yep, multiply by -1. You just take a number and you multiply by -1, it'll flip the direction of it. That's how bouncing works. So what I have you do is first I want you to press a button to make it bounce. Press return and it'll make it bounce in X. Then I have you bounce off the top wall. Then I have it bounce off the bottom wall. So once you do that, you're going to realize it actually goes off the bottom edge of the screen. So that's number 5, is solving that. And then have it move the ball diagonally and have it bounce off all the walls properly. So that's lab number 1. Lab number 2, I'm going to do a lecture before we get into that, but let me just show you. We're going to do gravity. So I'm going to talk about acceleration before we do this, so how we're going to have the ball drop. And then homework. I'll show you guys homework so you guys are aware of it. You're taking everything that you've done. You're going to make a cannon that fires with acceleration and gravity, with acceleration and velocity. Each of the keys is going to fire at different speeds. And then you're going to have it so that when you press spacebar, you press it. You're going to hold it. And when you release it, it's going to fire based on how long you held it. Okay. All right. Kind of like Hanzo Arrow if you guys ever played Overwatch. All right.